All right, everybody okay? You guys all able to find that, it looks like? So in this section for these identities, it's kind of a little different idea. It's using the same concepts that we were doing before. So notice that, many of these things I think look familiar, hopefully look familiar, tangent is sine over cosine, and cotangent is the reciprocal of that, and so on. So those are things that we've already talked about, but now we're going to be using those to kind of manipulate different expressions, okay? So there are a few things, kind of information that you'll need to know going in. You need to be pretty fluent with your reciprocal identities, okay? The fact that the cosecant is the sine flipped over and vice versa, by the way. And the secant is cosine flipped over, and that the cotangent is the tangent flipped over. Okay, so that would be something that we need to know, and we've talked about that a lot. Also, the quotient identities, we didn't refer to them in that name, but the fact that the tangent is the sine over the cosine, and that the cotangent is the cosine over the sine. In the next line, there's three what are called Pythagorean identities. You don't need to memorize all three of them. But I will say, this one right here, this is the greatest identity of them all. You should highlight that. You should star it. You should make sure that you absolutely positively know this identity, that the sine squared plus the cosine squared is equal to 1. We're going to use that all the time. It's the granddaddy of them all. It is the greatest identity ever. Have I emphasized that enough? It is the best, number one, the head honcho. It is all those things. So we will use that as we're doing some proofs a little bit later on in our notes. All right, but let's first start with part one, where we're trying to simplify these things. When we simplify, we want to ideally get things into one term. Sometimes we can't, but oftentimes we can't. So for example, in number one, the cosine of theta times the secant of theta. Well, remember the secant is the reciprocal of the cosine. So you can rewrite that. Left side is cosine theta, and the right side is 1 over cosine theta. Okay, because the secant is 1 over the cosine, right? Well, now to simplify that, we could just reduce it and cancel our cosines. Then we get 1. And so cosine theta times secant theta equals 1. It reduces to 1. All right, let's do part B, tangent of theta. Remember, tangent is sine over cosine. So when you're doing these, here's my suggestion. Always write things in terms of sines and cosines. That way we're kind of having them all in, a certain amount of functions. So like tangent, I'm going to write as sine over cosine. And the right side is the cosine. I'm going to leave it that way because I want everything in terms of sines and cosines. So cancel a cosine, because cosine, that's like cosine over 1. It's on top, meaning I can cancel one of those, and I'm left with sine theta. That is my answer. I have simplified it. Okay, any questions yet? All right, let's do, I'm going to do D next, and we'll come back to C, but let's do D. I want to write things in terms of sines and cosines, and none of them are right now. I know that the secant is the cosine flipped over. So 1 over the secant is cosine. Okay, or I could write it as cosine over 1. The tangent, remember, is sine over cosine. And the cosecant, remember, that goes with the sine, so that is 1 over sine. So I wrote everything in terms of sines and cosines. And now I'm going to try and cancel. And lucky for me, cosines cancel out, sines cancel out, and that whole big ugly thing simplifies to 1. So again, I think you can see, like, we need to be pretty fluid with these reciprocals here, okay? And we need to be pretty fluid with knowing tangent and, you know, if you know cotangent is tangent flipped over. So would you guys try C and E, and we'll go over those together in just a second. All right, which one do you want me to do first, C or E? C. All right, here goes C. The cosecant goes with the sine. It's the reciprocal of the sine. So I'm going to rewrite the top as 1 over sine theta. Okay, that's the cosecant. This is this. Now the secant is 1 over cosine. So I'm going to write that at the bottom as 1 over cosine theta. This is this. All right, now some of you got to here, but then forgot that dividing by a fraction is multiplying by its reciprocal, like we flip this guy over and make it multiplication. So I would do 1 over sine theta times cosine theta over 1. Again, I just flipped this over and made it times, so I'm multiplying by its reciprocal. And so that gives me cosine theta over sine theta. And the cosine over the sine is the cotangent of theta. So that simplifies to the cotangent of theta. All right, let's do E together. So again, we're going to write everything in terms of sines and cosines. So like the cotangent, I will write as cosine over sine. And the secant is 1 over the cosine. So our cosines cancel and we get 1 over sine theta. Now, some of you got here, which is great, but there is one more step. Because 1 over sine, remember, is the cosecant of theta. So that simplifies to cosecant theta. Okay, any questions? This is not so bad. We can do this. All right, well, let's scroll down then to the next part where it says prove. That is a big word. A proof means, in math terms, we already know the answer, but we have to show the work. So this question is saying, this is true. Okay, the tangent of theta times cosine of theta does equal the sine of theta. We just have to show why it's true. So that's the nice thing about doing these proofs is they always work. You're given the answer. You're not going to get to the bottom and it says, haha, doesn't work out. It will always work out, but we have to show the work. So to do that, we're going to manipulate the left side of this equation and try and see if it equals sine of theta. So let's do like we were doing before, write everything in terms of sines and cosines. So I would write on the left side tangent as sine theta over cosine theta. That's times cosine theta. And we're trying to show that that equals the right-hand side, which is the sine of theta. But I'm going to write RHS. That stands for right-hand side. Because sometimes it's longer than sine theta. It might be a big thing, okay? We're trying to show that the left side equals the right-hand side. And if I cancel those cosines, we do have the sine of theta, which does equal the sine of theta. And so I would say in terms of that identity that the left side, let's call 1 equals the right side 1, 1 equals 1. And that's a check mark, showing that I have proven that the left side equals the right-hand side. All right, part B. All right, we're trying to show that 1 over the cosecant times sine squared plus cosine squared equals the sine of theta. All right, well, let's start off and rewrite 1 over cosecant of theta is sine theta. Now, do you remember the greatest trig identity of them all that we set up here? Make sure you never, ever, ever forget that sine squared plus cosine squared equals 1. So the granddaddy of them all, the greatest trig identity, says that sine squared plus cosine squared equals 1. So I'll write another line just showing that sine theta equals sine theta. And so 1 equals 1. All right, any questions yet? So we're going to get maybe a little more tricky as we move forward here. All right, well then let's roll with it. Here we go with C. All right, I'm going to work on the left-hand side. The secant of theta is 1 over cosine. So I get 1 over cosine theta divided by sine theta minus sine theta over cosine theta. We're trying to show that that equals the right-hand side. All right, so for 1 over cosine theta divided by sine theta, that is going to simplify to 1 over cosine theta sine theta. Minus sine theta over cosine theta equals the right-hand side. Okay, like if you saw this sign as sine over 1, flipped it over, you would then get that. Well, this one's a little harder, but we have, we have to add these fractions together. And so to add those fractions together, we need a common denominator. And our common denominator is cosine sine, which means I'm going to multiply that part by sine over sine, which gives me on top 1 minus sine squared theta over cosine theta sine theta. All right, now if I lose you, please make sure you let me know. Because that left side is looking ugly, but it's going to get cleaner real quick. Because the greatest trig identity of them all, the granddaddy of them all, which is sine squared plus cosine squared equals 1. And I see that this is 1 minus sine squared. All right, follow me here, guys. If I were to take this and move that sine squared over, that would mean that cosine squared is equal to 1 minus sine squared. So I can use manipulations of that Pythagorean identity to rewrite the top here. 1 minus sine squared is cosine squared. And I'm almost there, because remember, I'm trying to prove that it equals the cotangent. If I cancel a cosine, I get cosine theta over sine theta. And the cosine theta over the sine theta is the cotangent of theta. So a lot more to that one. That one was definitely tougher. Yes. Yeah, so the question was, and this is a real common one, how did this turn into this? So remember that the trig identity of sine squared theta plus cosine squared theta is equal to 1. And that is accepted as true. Well, if I, using this equation, if I subtract sine squared to the other side, that would state that cosine squared theta is 1 minus sine squared theta. Okay, I just rewrote this. Sorry, I just rewrote this by moving the sine squared over. And so cosine squared theta equals 1 minus sine squared theta. So that means that wherever I see 1 minus sine squared theta, like here, I can replace it with cosine squared theta, which I did here. All right, so I know there's a lot to that. Yes. Perfect, you totally get it. So yes, it means that you also could say that sine squared theta is equal to 1 minus cosine squared theta. Yes, that you could use that in a proof. I just didn't do so because it was not advantageous at this point, but yes, you can do that. Great question. Any others? All right, should we do one more? Hurt your head enough? All right, well, maybe we'll leave D and E for our next class. Okay, because we will take another day on these, but I want to give you guys an opportunity to do some of these.